All right, we're gonna go back to weather a little bit. Okay. So, who remembers some types of weather really quick, just to refresh our memory? Julian.
Snowy.
Snowy, which we are in right now, aren't we? Lake.
Rainy.
Rainy. Emmett.
Rainy.
We already said rainy. Can you think of a different one? We've said rainy and snowy.
Sunny.
Sunny. Let's stop at sunny. That's the one I wanted. And also, I guess, when it's cold too. But we're going to start with sunny. So with sunny weather, what happens? It gets what?
Hot.
It can get very hot when it's sunny.
Yeah.
Just because the sun's out doesn't mean it's hot, but it can get hot when it's sunny, right? Does anyone know? We talk about it in calendar. When I tell you what the weather is, I also tell you what. I tell you how warm it is outside. Does anyone know what that's called? Remember what that's called? Corbin? There's a particular word for it. It's like how warm it is outside.
Like.
Starts with it. Does anyone know? It starts with the T. It's a long word. Jude, do you know? Not time. Eduardo, do you know? What is it? This is a tricky word.
Wendy.
No, not quite. I'll try one more. Levi. Starts with the T. It's a very, very long word. It's called temperature. Lake knew, thank you. Temperature is how warm or cold it is outside, right? I'll tell you in calendar, I'll say the high today, or the high temperature is 65 degrees. I'll say that is a temperature, right? So right now, would you say the temperature is hot or cold outside? What?
Cold.
Who thinks it's hot outside? You need to go step back outside if you think it's hot, because it is not hot outside. It is freezing. It is snowing outside.
No, it's not.
Bailey, sit down.
It's raining.
Okay. All right. So now that we've discussed temperature, I see Lake, and I see Lacey, and I see Ashlyn. There we go. All right. Now that we've talked about temperature, we're going to talk about something that we haven't really talked about that has to do with our weather and the Earth's surface, okay, and our atmosphere, okay? It's called air pressure. Air pressure.
I've heard of water pressure, but never air pressure.
Yes. Air pressure.
I heard of air pressure.
Does anyone think they know what air pressure is?
No.
Lake, what do you think air pressure is?
It's like water pressure.
Which is what?
The more lower you get, it gets heavier.
The more water you get, the heavier it is?
Yeah.
It's kind of like that.
And I can tell it.
All right, so our air pressure, not water pressure, our air pressure is kind of like what Lake said. So air pressure has to, you can't see it, right? We can't see air, right? No.
It's invisible.
It's invisible. With air pressure, sit back, Christopher, sit back. Okay, so with air pressure, the warmer the temperature, the more air pressure we have. And pressure is kind of like what Lake said. The warmer it is, the more pressure we have on us. Does anyone know what pressure is? It's like a force or something that's pushing against us. So I just am like pushing against the lake. It's kind of like what air pressure is, but we cannot feel it. We can't feel air pressure. We can't feel this air pushing against us. Okay? So we have air pressure and we have temperature. Now, when we have air pressure, the warmer it gets, the more the air pressure expands or spreads further apart. And inside the air pressure are these tiny little things that you guys cannot see. None of us can see. And they are called molecules. Say molecules.
Molecules.
Molecules. So when we have molecules, we cannot see them. They're these tiny little things floating around the air that we cannot see. And when it's warmer, they spread apart and there's more of them and they're moving really, really fast because it's warm. Okay? And when it's cold, they're closer together. And you can't see them. And they're closer together and moving slower. So remember, when it's warm, the pressure is greater, so you're going to feel it more. It's harder on you, okay? When it's colder, there's less pressure, okay? There's not nearly as much pressure. All right, so for our experiment, we're going to do something really, really cool, okay? So I have this glass bottle, okay? Doesn't have anything in it. I have an egg.
I can't remember if you're in the front row, stay crisscross, we can't see over you.
I need to peel this off. Okay. So I have this egg. It's a hard-boiled egg. Okay? Now, when I put it on here, can it fit?
No.
Can it fit in the bottle?
No.
No, it doesn't fit, right?
It's too big.
It's too big, the egg is. So, how many of you, raising your hand, think, I haven't said what I'm asking you yet, put your hands down. How many of you think that I can make this go into the bottle? How many of you don't think I can make it go into the bottle? Raise your hand.
Yes.
Raise your hand if you don't think.
No.
A few of you don't think so. Shh. Who says they think so? Raise your hand.
Yes.
Okay, Jude, how do you think I can get into the bottle?
By cracking it.
It's already cracked. It's a hard-boiled egg.
Okay.
So how do you think I can get this into the bottle?
I just quit.
Lake, how do you think I can get into the bottle?
Making it harder.
He's on to something.
Make
Now.
it harder. Just,
Okay. So do you guys think that when we try this, I'm not going to tell you what I'm going to do yet, but do you think that it'll go in or out?
Out.
How many think in? Raise your hand. How many think out? Okay, we have a few think it'll go out and a few think it'll go in. Okay, so what I'm going to do is I'm going to put a Kleenex in the bottle. Now Kleenexes are very flammable or can light on fire very easily.
Can you guys play with matches ever?
No.
Well, who do you need to have with you with matches? A parent or an adult. Right.
I had one. And it even goes up.
And it even...
Fire goes up.
Yes, and fire goes up. So this is not something for you guys to be messing with. This is just for adults. So you can do this experiment at home, but do you think that you can do it by yourself?
No.
No, you need help.
has to help you.
You need help from your grown-up.
And the little spots, you just rub it on there.
So are we ready to see what happens?
Yeah.
We have some people think it's going to go out, some people it's going to go in. So I'm going to light a match, and I'm going to drop it in here, and then I'm going to put the egg on. And we're going to see what happens, okay? So are you ready?
Yeah. I'm going to be scared.
Put it a little bit further.
Do you think it's going to be loud
Yeah. No.
or quiet?
Do you think it's going to be fast, or do you think it's going to be slow? Fast? Let's see. Oops, I broke it.
Let me get my iPad on the video.
All right. They're very flimsy. They're not very strong.
Tiny.
It's trying to crack it a little, or strike it a little too quickly. Okay, I'm gonna light the match. So the flame is gonna go out, and then it's gonna create smoke, and it's gonna make it go out. Is it going in?
Wow.
Okay, so what happened?
It got inside.
It did. At first when I lit the match, fire's hot, right?
Yeah.
It got warmer inside the bottle. Okay? But then did the fire go out?
No.
Yes. So the fire went out. And then it created what?
Smoke.
Smoke. Okay? And so inside the bottle, the air became cooler on the inside of the bottle than in the room. So the air pressure on the outside of the room was warmer than on the inside of the bottle. And what do we say when air pressure is warm? It's what? It pushes it pushes the egg down into the bottle. And that's how we got the egg to go into the
Think we'll
bottle.
be able to get it out?
You can get it out.
You can?
You can. I don't know if I'm going to be able to, but they said if you blow on the egg, I guess, or something, it's supposed to be able to come out.
It'll get colder.
I'm going to say if he pulls it again.
I don't know. We'll try it maybe later. I think you're supposed to be able to get it out though.
Oh.
That was pretty cool.
Yes.
Was it fast or slow?
It was kind of slow.
Motion.
I bet do you think if I lit another match, do you think it would go faster maybe?
Yeah.
Probably.
What if that napkin caught on fire and made a big fire? Yeah.
And then it
Did it
would
light
go
on
like,
fire? Yes.
it would just fall in.
All right, guys. All right. So that's about it for science today. You can go ahead and
Do it again.
on the
Do
video.
it again. Do it again.
Do it again with 2 matches.
Five. Make a big old.
Alright, this is my video, my reflection video over lesson 3, student engagement. And for students to be engaged, I feel like the best thing to do is just make the activity really, really fun, because I think they are more intrigued when it just completely interests them. They will listen to what you are saying to get to the fun part. So I tried to make an experiment that would be really, really fun for them, that they would enjoy. And I picked this experiment that had to do with weather, and air pressure, where the egg gets sucked into the bottle, and how air pressure is created when the egg is sucked in the bottle. And so for student engagement, what I did was I wanted there to be like discussion between the students and me, and I made questions for them that they got to vote on what they thought would happen to the egg. Did they think it was going to blow out, or did they think it was going to get sucked in? Did they think it was going to happen fast or slow? What did they think was actually going to happen to the egg? Did they think the egg could even fit in there to begin with? Was there a way to get it to fit into the bottle? Just questions like that I asked, and had them vote, and then they were able to see other people's opinions and answers as we went through the experiment. The last thing I did was the experiment and showed them what actually happened. And it went really well, and the students were able to actually the students actually did a very good job of understanding air pressure, the very, very basics of air pressure and how it works. Students were, for what I thought, they were really engaged. I thought I did a really good job of keeping them intrigued with what we were doing. there were really no problems that went wrong during our discussion. Honestly, the students behaved really well, I thought, during the discussion, and they all voted and they all participated when I was asking the questions. The only thing was they kind of maybe got a little squirrely on the rug and were like looking at, like getting closer and closer, looking at what was going on for the experiment. So it was hard somewhat to keep them contained, I guess, while I was talking a little bit, because they were so excited to see what we were going to do with it. And then after I lit the match, we also discussed what actually happened to the egg, why it happened, and if we could figure out what happened. And they really did a good job. Some of them understood, a lot of them understood how air pressure affected the egg. That's another thing that maybe one of the things they can maybe work on is next time find other ways for them to understand air pressure more, or the topic that we're discussing more, using like technology or other manipulatives in books and visuals, because they didn't really have a lot of that. It was more just us discussing and then what was right in front of them from my manipulatives and what I was using, because it'd be really hard for them to do that. They can't do this experiment, obviously, because there's matches in fire and they should not be messing with that. But for what I would change next time is I would try to add more like technology and books and other visuals to my experiment with the students. But overall, I felt like they were engaged and they were intrigued in what was going on, and it was overall a really fun activity, and they learned something from it. They were able to understand how air pressure affected the egg and why it went into the bottle, which was the main purpose of this experiment.